Is that correct? Lambda x, x minus y. Yeah, this is correct. Okay, fine. Now let's subtract f of y. So all that I'm trying to do is see what the derivative is or the gradient is, right? So what should I do? It's like f of y plus, if lambda is very small, right? So I'm moving in the direction of x minus y by a small quantity and looking at what the function value is, right? If I subtract by f of y and divide by a small quantity and take that limit, I get the derivative, right? That's what I'm trying to do. So let me subtract f of y on both sides. So what do I get? F of y plus, is it lambda times x minus y is less than, okay, I'll subtract f of y on both sides. This is less than or equal to, what do we have on the right hand side? Lambda f of x plus f of y. I subtract, so this times this f of y is times 1 is f of y, and I subtract f of y, so they cancel. So I have minus lambda f of y, right? So it's lambda times f of x minus f of y, right? This is lambda times f of x minus f of y. Okay, this is what I have. Now I'm going to divide it by lambda, right? So what do we have? F of y plus lambda times x minus y minus f of y divided by lambda is less than or equal to f of x minus f of y. Is that okay? Is that okay? Now, take lambda to 0. I can do that, right? So it's any lambda between 0 and 1. So I'm going to take lambda to 0 from right. Okay. Of course, I'll ensure that my lambda is between 0 and 1. And my lambda, I'll take it from here to 0, right? I'll take such a sequence. Now, what happens to this left-hand side? Can somebody tell me? See, I started y and I'm going to move in the direction of x minus y by lambda, right? I'm going to look at the value there and value here and look at the difference. But I'm going to shrink that x minus y length, right? So by multiplying by lambda. So what do you think you get? I get the derivative, which is the gradient, in the direction of x minus y, right? So how do you find the derivative in the direction of x minus y? What is the gradient in the direction? How do you find that? What is that called? Huh? What is the component of x in the direction of y? Okay, you should answer that. What is that? How do you compute that?
Projection.
Huh?
The projection of that
Projection, right? So what is, how do you get the projection?
by the inner product.
Okay, what is the inner product in Rn? Typical inner product. X along y is x transpose y, right? That's the inner product, right? So gradient along x minus y is what? X minus y transpose times the gradient, right? So this implies x minus y transpose times the gradient of f at y is less than or equal to f of x minus f of y. So this implies f of y is greater than or equal to, f of y is less than, no, I think I should write it in terms of f of x. F of x is greater than or equal to f of y plus x minus y transpose gradient of f of y. This is interesting, right? This inequality. Now let's compare this with the remainder form. Okay, x and y are 2 points. Let's look at f of x around y. So what is the remainder form? Let's see the remainder form now. So f of x around y, right? So it's f of y plus x minus y transpose times the gradient of f at y plus, I stop at the second order, x minus y, oh my god, x minus y transpose what else? The Hessian of f at some point x star, I don't know what that point is, times x minus 1 by divided by 2, right? Where x star is some point between x and y, right? You take some point x and y, x and y. I don't know what that x star is, but this is true. Now, see, f of y plus x minus y times the gradient. So it's the gradient in the direction of x minus y plus higher order term. What do we have here? F of x is greater than or equal to f of y plus x minus y transpose gradient of y. You stop there, you get an inequality, right? F of x is greater than. That means if I, by adding this quantity, I get equality. By removing that quantity, what do we get? The function value, I mean the right hand side goes down, right? So that means this has to be positive, right? And it does not matter what x and y you pick. Do you agree? You pick any x and y in the domain, it's true, right? What is that called? This implies x minus y transpose the Hessian of f of x star x minus y is greater than or equal to 0 for every xy in the domain of f, right? And for some x star in xy, right? This is true, right? You agree? Now, if I ask the reverse question, suppose, okay, well, what does this mean? Suppose this is true for so any xy, right? That means any x minus y, it's true. That means you take any vector v, v transpose Hessian v is greater than or equal to 0. So what does that mean? The Hessian is positive, semi-definite, right? So now, what can you conclude from this? Okay, so I'll pause here for some time. So what can you conclude from this? We started with convex, right? We showed that for convex function, this is true. But we didn't show that if this is true, then f is convex, right? Did we? No, we didn't, right? But we showed that if the function is convex, this is true, right? But this can be true. If this is true, what else can be true? So this is also true, right? F is convex, that implies some inequality, that implies that it's positive, semi-definite. So that means if the function is convex, then the Hessian should be positive, semi-definite, right? Is that fine? Okay, so if f is convex, implies what? The Hessian is positive, semi-definite. Now the question is this true? If Hessian is positive, semi-definite, can you conclude that it's convex? Yes or no? That means if Hessian is positive, is semi-definite, definitely this is true, right? This inequality is true. But the moment this inequality is true, if you can prove that it's convex, then we are done, right? So now, obviously, the question that we will ask is, if f of x is greater than or equal to f of y plus x minus y transpose gradient of f at x, this implies f is convex. Or sorry, implies f is convex, right? So this implies positive semi-definiteness. So that's what we asked for. F is convex, this is positive definiteness. If the Hessian is positive semi-definiteness, is it convex? So that means if f is, the Hessian of f is positive semi-definite, this inequality is true. If that implies f is convex, then we are done. Okay, now can somebody tell me the idea? So what should we do? We should prove that this is convex, right? How do you prove that this is convex? How do you prove that this thing is convex?